Hello everyone, welcome to Reactify Labs. Today we will talk about pub sub or publish subscribe model. Pub sub model. Mm, Pub sub model, okay? So, what is pub sub model? As the name suggests, publish, subscribe. So, somebody is going to publish something and somebody is going to subscribe to that publishing. So, basically, it's like YouTube. Take an example of YouTube. Hmm? When you subscribe to a channel, so you just subscribe, okay? So in that, what happens when you open YouTube, if that channel has posted a video, you might see it on your screen, okay? Or maybe when you're scrolling, you might see that, okay, this is a video suggestion from the channels that you have subscribed, yeah, subscribed basically. But when you press the bell icon, hmm, when you press the bell icon, in that case, what happens when that channel publishes the video you get a notification, right? So it means basically both are pub sub. Actually, when you just subscribe, that is also a pub sub. When you press the bell icon, that is also a pub sub. But there are different kinds of pub sub. This one will this one you are subscribing to, like, okay, when this channel uh, uploads a new video, show it to me, show on my maybe timeline or home page, okay? But this one is, again, here you are subscribing to, okay, when this channel posts a video, uploads a video, notify me, okay? So this one notifies you, this one does not notify you, right? So this is the difference. So there are different kinds of pub sub model which exist, right? So it depends on what kind of subscription you have done. Again, everything is a pub sub model. Mostly, if you see, if you do a subscription to, let's say, Prime Video or Netflix, that is also a pub sub model. You are subscribing to the video content platform, actually, not the content only. So once you paid them whatever X dollars, it means you have subscribed to them. So whatever video, whatever content has been posted on their platform, you get access to that, right? So again, this is again a pub sub model. Means here, that's not one content or one event you have subscribed to. Here you have subscribed to that platform itself, that whenever whatever is there in that platform, you should have the access to it. So that's the pub sub, right? When you tell your friend that, okay, see, as soon as this guy, let's say you have to do some kind of gossip about some person X, and you say, okay, whenever this X does something, tell me that gossip. Again, you are subscribing to your friend, right? So here X becomes the publisher. So X, not really, X becomes the bearer, okay? And your friend is the publisher of the news, and you are subscribing to your friend that, okay, tell me, let me know the secret, okay? Let me know the gossip about that person. So that's also a pub sub model. So somebody is going to publish the secrets about X, and you are subscribed to that. Yes, that is what I wanted to know, right? So yeah, now that we know an analogy to it, it will be easier for us to understand the technicalities. So let's discuss the flow that we are going to follow today. So we will start with the introduction. So in the introduction, we will talk about publish subscribe model in very brief. Next, we will see what are the core concepts involved in the pub sub model. Next, we will see the technical details of it. See the technical details associated with it. After that, we will go into the implementation details. Implementation details. Next, we will move to advantages and challenges associated with pub sub model. Okay. So yeah, let's start with introduction. What is pub sub model? The pub sub model is a messaging pattern. It's a messaging pattern where, as the name suggests, publishers send messages to a channel. Publishers send messages to a channel or a topic. You can say it as channel or a topic, and subscribers receive messages. And subscribers receive messages from those channels. From those channels or topics. So this model, what it does is, if you see, publisher has published somewhere, subscriber has subscribed to this. So publisher and subscriber are decoupled, right? So this model decouples the message producers from consumers, allowing for scalable and flexible communication. Okay. Now let's talk about the core concepts of pub sub model. So first one is obviously publishers. So publishers are the entities that generate and send messages or events to a channel or a topic. Publishers are responsible for producing and broadcasting messages without knowing who will consume them. For example, in a news system. So journalist who writes the articles and publishes them to a news feed do not know who are going to watch that news, right? So that's the similar role of a publisher, okay, or publishers. Next, there are subscribers. So subscribers are the entities that express interest in receiving messages from one or more channels or topics. Subscribers process or react to the messages they receive. Again, news readers or applications that display the articles from a news feed, they are subscribers. Next is channels or topics. Channels or topics. So channels are the immediate structures where messages are published and from which subscribers receive messages. Channels or topics act as the communication medium. For example, a sports topic in a news system where articles related to sports are published. Again, let's say there is a movie column, movie topic or movie channel in a news, so there news related to movies will be published, right? Next is message brokers. Sorry, it's 4. Message brokers. So message brokers are the systems or services that facilitate the pub sub pattern by managing the channels or topics, routing messages and delivering them to subscribers. Examples again like Apache Kafka, RabbitMQ. I have talked about this in my event driven architecture video as well, right? So yeah, brokers are those which facilitate this publish subscribe. So yeah, now that core concepts are over, let's talk about the technical details. Technical details. So in this, we are going to talk about a few things. First is message flow. Message flow. Second is decoupling. Third is message delivery. Message delivery. Fourth is message brokers. Message brokers and middleware. And fifth is quality of service. Okay, so let's start with message flow. This message flow, in message flow, what happens is publishers send messages to a topic or a channel. The message is then stored and made available for subscribers. Subscribers register interest in specific topics or channels and receive messages from them as they arrive. This is again similar to what we have discussed. Next, decoupling. Again, the same thing. Publishers and subscribers operate independently. Publishers do not need to know about the subscribers and subscribers do not need to know about the publishers. This decoupling allows for easy addition or removal of publishers and subscribers without affecting the overall system. That's why we say your system should be as loosely coupled as possible, right? Next is message delivery. Messages sent to a topic are broadcast to all subscribers of that topic. Each subscriber receives a copy of the message. There is something called queue-based delivery as well. In some implementations, messages can be placed in a queue or in different queues and consumed by subscribers based on their availability. Let's say they are not available to consume now. So in that case, the message will be placed in that queue, right? Next is message brokers and middleware. So brokers handle the routing of messages to appropriate subscribers based on topics or channels. Brokers may provide durability by persisting messages to disk, ensuring that messages are not lost even if system fails. As I talked about here, this message brokers. So they provide additional functionalities. They provide additional infrastructure for persistence of the messages, or providing additional capabilities to the message delivery. Okay. And next is quality of service. So there are three kinds of QoS basically. So it's QoS 0, QoS 1 and QoS 2. Okay. So QoS 0, let's talk about QoS 0. The QoS 0 is at most once. At most once is messages are delivered once, but there is no guarantee of delivery. This is the fastest but less reliable method. Let's say you prioritize speed, fast delivery of the message over reliability. So what happens is you just send out the messages to everyone. And if let's say some message fails in the way, or some get lost, or the system was down, subscriber was down, you do not care about this. Okay. So it means whoever was online or whoever was able to receive the message received it, right? So this is QoS 0. It's basically also called at most once. So your message will be sent only once. If it got received, then that's fine. Otherwise, no. Okay. Next is QoS 1. QoS 1 says at least once. So messages are guaranteed to be delivered, but duplicates may occur. This balances reliability and performance. So messages will be sent out multiple times. It's possible that they sent out the message and for one of these, the acknowledgement did not come. So it will never know if the message succeeded or not. So this might send the duplicate. It's possible that the message got delivered, but the acknowledgement got lost. It's also possible that message got lost. So if the message was lost, then there will be no duplicates. But if the acknowledgement lost, then there will be duplicates. So in the QoS 1 strategy, which is at least once, there is a possibility of duplicates. Okay. And third is QoS 2, which is exactly once. So messages are guaranteed to be delivered once and only once, right? So it means it might send multiple times, but only when they know that, yes, okay, it has failed, okay? Or the acknowledgement, something, it's not acknowledgement. If the message failed, only then it will resend. And once, exactly once the message will be delivered. So there will be no duplicates, but it comes with an overhead. It has to maintain a lot of communication to make sure that the message has been delivered and it has been delivered only once. Okay. So yeah, this was all the QoS. Okay. Next, first let's change the color and then move to another topic called implementation details. Implementation details. Okay. So implementation details will be about different kinds of message queues or event brokers or message brokers, whatever you say. So let's talk about a few things in very brief. Apache Kafka, RabbitMQ, and Google PubSub. Okay. So Apache Kafka. Kafka uses topics to categorize messages. Each topic is divided into partitions, allowing for parallel processing and scalability. Consumers can be grouped to share the workload. Each partition is assigned to only one consumer within a group. Okay. Next, RabbitMQ. RabbitMQ uses exchanges to route messages to queues based on routing rules. Subscribers consume messages from queues. Exchanges are bound to queues with routing keys, determining how messages are routed. And Google PubSub uses topics for publishing messages and subscriptions for receiving them. Subscribers receive messages from subscriptions. PubSub supports both push and pull delivery models. So push is messages are pushed to the subscribers. So subscribers are subscribed, and as soon as the new message comes, it will be pushed. And the pull mechanism is messages are messages are posted, and when subscriber wants, they will pull the message, right? So both have their own advantages and disadvantages. Pull and push mechanism. I think I have talked about this in the CDN video. Please go and watch it if you have not watched that already. Okay, again changing the color and talking about the advantages of PubSub model. Advantages. First is scalability. It supports a large number of publishers and subscribers because they are decoupled and making it suitable for scalable systems. Next is flexibility. It allows dynamic addition or removal of publishers and subscribers without affecting other components. Next, decoupling. It reduces dependencies between message producers and consumers, leading to more modular and maintainable systems. And real-time updates. It enables real-time message delivery and processing, making it ideal for applications that require timely updates. Okay, and the challenges associated with this architecture. First is message ordering. So ensuring the correct order of messages, especially when messages are distributed across multiple partitions, can be challenging, right? Because if this is the partition, you can know, okay, what will be the order of messages here. But if there are multiple partitions, then you would not know what will be the order of messages, right? So there is some, I think, coding question in which you are asked to merge two sorted arrays, right? It's this similar kind of problem. Merge two sorted arrays. How will you merge them if you don't know the order of the other partition, right? So yeah, this is a challenge that exists and it needs to be handled. Next is message duplication. So handling duplicate messages can be necessary, particularly in at least one delivery scenarios, right? Because we do not want duplicates, right? If there are too many duplicates, it would overwhelm the system with unnecessary data. Next is complexity. Managing and configuring message brokers and ensuring reliable message delivery requires careful design and monitoring. And scaling brokers. So as the number of topics, channels, and messages increases, the broker infrastructure must be scaled to handle the load effectively, right? So yeah, that's all there was in this video. I hope this gives you a good idea of how publish subscribe works. In my other videos, I have talked about PubSub. In the event driven architecture also, I talked about PubSub. So you might be having this question, what is PubSub? So that's why I made this video, to clarify what actually PubSub is and what role does it play in event driven architectures and what role those message brokers play in this PubSub model, right? So yeah, again, if you take an example of something like let me try to recall that. Webhooks. Yeah. So in webhooks, what happens is you subscribe to something, right? So let's say I gave the gym example, right? So you maintain a gym and you have just added a webhook so that any membership changes or any change in the gym gets delivered to you, right? You get the updates in real time. So that's what webhooks do. So webhooks are also a form of event-driven architecture, which aligns with the PubSub model, right? Publish subscribe model. So webhooks act as a mechanism for delivering real-time notifications to subscribers when certain events occur, right? The publisher sends events to a topic, and subscribers, which are the webhook endpoints, receive notifications based on their subscriptions to that topic, right? Again, this helps in achieving decoupled communication. So if you have not watched the webhooks video, I suggest please go and watch that. You will be able to relate this pub sub model more with webhooks. Okay, and event driven architectures definitely. So yeah, that's all. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.